Okay, we're back. This time we're going to look at the parallel lines with those angle pairs that we talked about in the last video. We have to know which angles are corresponding. We have to know which ones are alternate interior. We have to know which ones are same side interior, or what we call consecutive interior. And we have to know which ones are the alternate exterior angles. Because if we know which angle pair it is, then we know something about it. As you did in the investigation I wanted you to do, you went into GeoGebra, you created parallel lines, you measured all the angles at each intersection, and you noticed that there were the ones at each intersection across from each other that were congruent. Those were those vertical angles. We know those are congruent. We already have a theorem for that. But I made you take a look at the angles from one intersection to the other intersection to see what was going on with those at those places. And I wanted you to actually look very closely at those angles and come up with a conjecture. Now, hopefully your conjectures are going to match what we have in this video. So let's get talking about these parallel lines and other items along those lines. Okay, so here we have a set of parallel lines. M and L are parallel. Remember that this two double line mark here, M double line L, means parallel. It's the two L's in the middle of parallel. So here I have line T, that must be the transversal because it's crossing the M and L, and it creates those 8 angles. Now we already know that certain angles here are certain types. We know that angle 1 and angle 3 are corresponding. We know that angle 7 and angle 3 are alternate interior angles. We know that angle 2 and angle 3, can't even get that to show up, are same side interior angles. We know that angle 1, let's do 8, angle 8 and angle 4 are alternate exterior angles. We know that. So now what we're going to look at is what happens when we do know that and where can we go from that. So let me minimize that. I don't want to move that. I want to move this. There we go. We're going to talk about some postulates and theorems, and every one of them start off the same way. If two parallel lines are cut by a transversal, so if line M and L are parallel and they're cut by line T, then what happens? We get the corresponding angle postulate. And this postulate is pretty neat. It says that each pair of corresponding angles is congruent. Angle 1 and angle 3 have to be the same measure. 2 and 4 have to be the same measure. 8 and 6, same measure. 5 and 7, same measure. So if I have parallel lines, I know I have congruent angles. Those ones that correspond in the same spots are congruent. That's a postulate, meaning we can't prove that. We just know that it happens to be true for parallel lines. And that was something you noticed when you did your GeoGebra assignment, if you actually did it. Now, that leads us to a theorem. Theorem 3.1, the alternate interior angles theorem. It's a theorem, meaning we can prove it. And I'm going to ask you to prove it on the assignment. Each pair of alternate interior angles is congruent. So angle 2 and angle 6 are congruent. How can you prove it? Then we have the theorem 3.2, consecutive interior angles theorem, or if we want to refer to it as same side interior angles theorem, our current textbook calls them consecutive interiors. That's why I brought that up in the definitions the other day. So this is saying, talking about angles 2 and 3 and 6 and 7. I asked you to look at that in GeoGebra 2. Hopefully you said something along the lines that each pair of those consecutive interior angles is supplementary, meaning that they add up to 180. So 2 and 3 have to add up to 180. I'm going to ask that you prove this theorem as well in an assignment. Get on to that. So, okay, then we have theorem 3.3, alternate exterior angles theorem. So this is our 1 and 5 angle. This is our 4 and 8 angle. How are they related? Well, what we found out in our conjectures is that each pair of alternate exterior angles is congruent. So with that, if I have two parallel lines and I have a transversal, and I know one of those 8 angles, I should know every angle in that entire deal. Every single one. Should be able to figure them out all. Just click a which. Okay, so now, that leads us to this really funky theorem. It's called the perpendicular transversal theorem, theorem 3.4, and it's because it's still starting with parallel lines. So if I'm in a plane and I have two parallel lines and I have a transversal comes through it, and it happens to be perpendicular to one of those two parallel lines. So like angle 1 is a 90-degree angle. So I know it's perpendicular, so T would be perpendicular to M. It means it has to be perpendicular to L. Why does it have to be perpendicular to L as well? Well, let's go back up. We know that the consecutive corresponding angles are going to be congruent. We know that the alternate interior angles are going to be congruent. We know that the alternate exterior angles are congruent. So here's the thing. If angle 1 in that figure from above, if angle 1 was a 90-degree angle, it automatically means that angle 3 has to be a 90-degree angle. It also means that angle 5 would have to be an angle 1 and angle 3 would have to be a 90-degree angle because of the corresponding angles postulate. Angle 5 would have to be a 90-degree angle because of the alternate exterior angles theorem. So I could use either one of those two, and as long as 3 or 5 is a right angle, that means L would have to be perpendicular to T also, which is what this theorem said. So I just proved that one for you. Okay, so now let's see if we can actually put these 4 theorems to use. So here I have this figure. Ooh, it's big. I have to shrink that down just a little bit here so I can get all these problems up here. Okay. They want us to find the measure of some angles here. There we go. And they say in that figure right there, angle 5 is a 72 degrees angle. So I'm going to write that on there. That's a 72-degree angle. And angle 9 is 102. And this is 102 degrees. That's given information for us. Now, they want us to find 1 and 13 and 10 and 4 and 7 and 16. I say we find them all. Let's find them all. The first thing I would do here, and you may or may not agree with me on this, but that doesn't matter. I'm going to do it anyway. I'm going to go to a got to get some stuff here so that it'll work right. Okay. I'm going to hide this set of information right now. That'll work. I don't want to look at those angles. I just want to look at this set of angles over here. If 5 is 72, that means 8 must be guaranteed to be 72 degrees because those are vertical angles. 5 and 8 are vertical angles. It means 13 has to be 72 degrees because it's corresponding with 5, and it's an alternate interior with 8. It means 16 has to be 72 degrees because it's corresponding to 8. It's an alternate exterior with 5, and it's a vertical angle with 13. So those all have to be 72-degree angles. Now, with that being said, I can automatically figure out what the other 4 angles are because 15 and 16, or 13 and 14, or 7 and 8, or 5 and 6, whichever pair you want, they're a linear pair. And as the linear pair postulate tells us, if it forms a linear pair, then they're supplementary. So this has to be a 108-degree angle at 6, and at 14, and at 15, and at 7. That's a 108-degree angle. So all of those are known to be those values. They have to be. That's the only way that can work. So now when I look down here, it asks what's the measure of angle 13? Well, I got angle 13 at 72 degrees. What's the measure of angle 16? I got it at 72 degrees. What's the measure of angle 7? I've got it at 108 degrees. So I've got all those angles already accounted for. Okay, so now let's move this to the front. And let's slide it to the other side, and let's turn it. That way you can hide out my other values, so I can just look at those sides. Now, what we know here is that angle 9 is a 102-degree angle. Well, that means I have a bunch of other angles as well. Right here with a brighter color. So, it's too bright. Got to get my recorder out of the way. Let me go with an orange. Okay, so 12 has to be a 102-degree angle because it's vertical. 4 has to be a 102-degree angle. 1 would have to be a 102-degree angle because those are all in that same set. 9's vertical with 12. 9 is alternate interior angle with 4. 9 is corresponding to 1. So they all have to be the same measure. Now I can figure out the other angles that I'm missing there. 9 and 102 and what gets me 180? That'd have to be a 78-degree angle, which means 10 is a 78-degree angle, which means 3 is a 78-degree angle, which means 2 is a 78-degree angle. Now that I got all those angles figured out, I can figure out what they want. They want the measure of angle 1. 1's 102. Angle 4 is 102. Angle 10 is 78. So we figured out all those angles, and if we actually take a look here, we know every angle. We know measure all 16 angles in that figure just by simply knowing what one of the angles was on each side. We got them all figured out. Now, is it going to be always that easy of a problem? Well, no, we know that's not the case. So here it says find the value of x and y. So what number goes in for x and y to make these things true? And we're given these two funky little figures. 8 looks like a triangle with some parallel lines in it. 7's got multiple parallel lines in it. Now, they got some neat information in here I think I need to point out. That's this right here. Okay, take a look there. There's 2 triangles on that. Our symbol for parallel was a single triangle. We talked about that one other time, I believe. So when we see those, we got parallel lines. So these 2 lines are parallel. Notice all 3 of those have a single triangle. So that means all 3 of these lines are parallel to each other. Okay, so now with that being said, and I've got that 75-degree angle, I should be able to figure out all the angles in this thing. So that means this has to be a 75-degree angle because it's corresponding. This angle over here would have to be 75 degrees because it's corresponding. The angle right here beside it, this one right here, would have to be 105 degrees because it's I keep knocking something else in there. So this would have to be 105-degree angles because 75 and that 105 are same side interior, consecutive interior angles. They have to be supplementary. Now the other thing I notice is the 9y minus 3 is also in a 105 spot because it's corresponding to the one I have. So now I have what I have. I can set up the equation. I can say 8x minus 5 has to equal 75 and solve for x. I'm going to add the 5 to both sides. I get 8x equals 80. Then I'm going to divide both sides by 10. That's equal, yep. So x is 8. So if I put an 8 in there, whoa, back up. Hold the phone. I need to divide both sides by 8. I'm dividing by 8 on both sides the same. So x is 10. Now if I put a 10 in there, 8 times 10 is 80, minus 5 is 75. So x is 10, that works. Now let's look at the other one. I got 9y minus 3 has to equal 105. So I would add 3 to both sides. So that gives me 9y is 108. Then I would divide by 9. I don't know where that 10 came from on the other one. I think I might have already divided it in my head, so that's what it was. Okay, 9y divided by 9. Those are both equal, so that's good. I get y. 108 divided by 9, y. 108 divided by 9 is 12, so y is 12. And if I plug that in, 9 times 12 is 108, minus 3 would be 105. That works out. Now let's look at the other figure. As I look at it, I've got parallel lines inside a triangle. So this angle here, I'm going to assume has to be 55. So that means 4x plus 7 equals 55. So what am I going to do? I'm going to subtract 7 from both sides. So 4x equals 48. I'm going to divide by 4. That gives me x equals 12. So x is 12. Let's see if that works. 4 times 12 is 48 plus 7 is 55. So that works out. Well, now I got to figure out what that measure of angle y is. Angle y is that whole top part of the triangle. Now we haven't actually talked about triangles yet, but you already know a feature about triangles, and that is the 3 angles of a triangle add up to be 180. You're going to have to be proving that later on. So just so you know. So I've got 55 plus 60 plus y having to equal 180. And I got to figure out what the y is. Well, 55 plus 60 is 115. So y would have to be 65 to get all the way up to 180. Okay, so that's the type of problems you're going to see today. They're going to just give me something real simple, tell you a measure of it in there, and then they want you to find angles out of it. For me, I just kind of play what a former student of mine used to call the angle game. Once you have one, you should be able to figure out all the angles in that deal. And then they're going to give you some where you're going to have to do some algebra to solve it. Okay, you're ready to go now.